show where you can watch me, Rachael Linesegment, and to bake some delicious confections. Today we will be making a fun-setting sign of X, some blueberry muffins of revolution, and a parabolic Cookulus cake. But first, look under your seat. Everyone in the audience has just won a free TI 83+, the capability to grasp all of your cooking needs. Let's get started. Our first cake, the fun-setting sign of X, is a fairly simple cake to make. The first step is to make the cake. I'm not gonna lie, it's just cake mix with all the normal things you find in the cake.
Oh, that's hot. It's step 2 that gets tricky, cutting the cake into the sine wave shape. I actually used 2 sine of 0.5x plus 6. I used frosting to draw the shape into the cake. Then I cut along the outline. As you can see, this is the kind of shape that you couldn't find the area of using basic algebra. You can estimate the shape using rectangles that you can find the area of. But as you can see, there is some error. Using an integral takes care of this problem because an integral adds rectangles with an infinitely small width. Since this sine goes from 0 to 13 inches, which can be shown by the graph in the first quadrant, the integral is 2 sine of 0.5x plus 6 dx from 0 to 13. You can integrate this with your calculator, and you find that the area is about 78 inches squared. Since the cake is about 2 inches deep, the volume is 156.18 inches cubed. The next thing we will be making today is more difficult. Muffins! In the sine cake, we were able to add lengths to find an area, and then multiply by a constant depth to find the volume. We can also find a volume by adding areas, assuming you know the equation of an area that makes up a slice of the volume. We have to find this equation experimentally. I started by tracing a muffin half. The muffin was measured, and data points found. The straight part was roughly a line, while the rounded muffin top roughly follows a cubic shape. Regression lines can be found using the TI 83+. The area under this line right here and then around this hump, in there, is roughly half muffin shape. So if this were revolved around the x-axis, it would make a muffin. This muffin could be divided up into horizontal discs, each with an infinitely small thickness and a known area that can be found using pi r squared, where r is the y value. These discs can be added to make the volume of the muffin. Now the equation for area must be put into the integral. So the 2 integrals we need are, for this part, for the straight part, since it's about 3 centimeters, it's the integral from 0 to 3 of pi times the quantity 0.217x plus 2.35, all that squared, dx. And then for the curvy part, it's a cubic function, so from 3 to 6 centimeters, it's the integral pi times quantity negative 0.113x cubed plus 0.705x squared plus negative 0.257x plus 0.559, all of that squared dx. The total volume works out to be about 153 centimeters cubed. The next cake is the biggest challenge to make and to integrate. This area right here is roughly a parabola, the regression lines of which can be found by tracing a slice and then measuring. So, this cake is the shape of an entire parabola rotated around a vertical line, or two parabolas, because this side actually changes slope more rapidly than this area, so it's two parabolas that meet in the middle I used. But the volume of this can't be found the same way that the volume of the muffins were. The radius depends on the x value, and the x value can't be given as a function of y, because there are two y values for every x value. We have to use the shell method. Instead of using disc-shaped cross-sections, we will be using shells that fit snugly inside each other to make a hole. These shells are just hollow cylinders, the surface area of which can be found using 2 pi r for the circumference and then multiplying by the height. The radius of each cylinder can be found by subtracting whatever x value you're at from the line 12.213, because the end of the parabola, it ends at 9.713. And since the hole at the bottom has a diameter of 5 centimeters, the end of the parabola must be 2.5 centimeters away from the line you're going to revolve it around. And then the y value, the height, is just the y value at that x. The thing we actually have to enter into the integral is the equation for the surface area of the cylinder, which, remember, we have two regression lines. So the first integral will go from negative 0.468, because that's where my regression line crosses the x-axis, to 4.714, because that's where the two regression lines cross. The second integral will go from 4.714 to 9.713. And then what's inside the integral is 2 pi times the radius, which again is the line 12.213 minus the x value. Then we multiply by the y value, which is just, the regression line. Thank you for watching Cookulus with Rachael Linesegment. Please tune in next week.